Well, hello, gay. Let's try that one again. That was a disaster. Sorry, still feeling a little bit ordinary at the moment, but let's try and say that again. Hello again, year sevens. See what happens when I slow down? I can actually pronounce my words. Exercise 8I. This is the last one, I think, for this chapter 8, and we're looking at experimental probability. If you remember last time, we looked at theoretical probability. So we work out theoretically what we should get from a particular trial or an event or something happening. So if we're going to roll a die, theoretically, if we're going to ask if what's a probability of getting a 3, still can't speak, but we'll battle on. Theoretically, it's 1 out of 6, okay? But if we actually roll a die 6 times, a 3 may not come up at all, or it might come up 3 times out of those 6 rolls, okay? So theoretical probability is, again, what we maybe should get. Experimental probability is what we actually get if we conduct trials. All right. So the experimental probability of an event occurring is based on particular experiment is defined as. Now, last time we had a formula, okay, which is the number of times a particular event could occur. All right, over the total number of possible outcomes. So this is very similar, but it is also different. So make sure, again, this is written down on your note-taking sheet and you highlight it and whatever else you need to do, because this is the important formula that you need to have. All right, it's a little bit different to the theoretical one, but also, it's also similar a little bit, but it is different. So make sure you do know the difference between your theoretical and experimental probability. All right, so again, we write as a fraction, and then we write it as either decimals or percentages after we write as a fraction. But always write as a fraction first. So our top number that we write is the number of times the event actually occurs. If we're rolling a dice and we're saying what's the probability of getting a 3, if we roll the dice 6 times and the 3 occurs 3 times, that's what we write on the top here. Okay, it's the number of times the event actually occurs during our trials. Okay, and the bottom number this time is the total number of trials we have. So if we roll a die 10 times, 10 would be our bottom number. If we roll the die 50 times, 50 would be our bottom number. If we roll the die 1,000 times, then 1,000 would be our bottom number here. Okay, so top number is number of times the particular event that we're after, that we requested, occurs, and the bottom number is the total trials or experiments that we actually do. Okay, so again, if we spin a spinner, when we spin the spinner 15 times, then 15 would be our bottom number. All right, so hopefully that makes sense to you, and is a little bit different to theoretical, so make sure you get your two little formulas for theoretical and experimental probability sorted. Okay, so the expected number of occurrences is the probability multiplied by the number of trials. Okay, so we can actually, from an experiment, we can then predict, or try and predict how many times a particular occurrence will happen in the future. All right, so just say if we got the probability of, rolling a 3, 10 times and 3 came up 3 times, okay, so that's 3 out of 10. All right, and we say, okay, if we got 3 out of 10 rolling the die, what if we rolled it 1,000 times? Okay, so you take your 3/10 and you multiply by 1,000. Okay, then you say, well, if we did the trial 1,000 times, then we can then predict how many times the 3 would come up based on the results we got from our actual trial. All right, so we can get expected outcomes, or the expected probability of something happening, okay, based on our own experimental probability that we did. So the actual results we get, we then try and predict if we did more trials, how many times that particular outcome will occur. Okay, hopefully that makes sense. It'll make more sense when you do the actual textbook work or other activities that we might do, but that's what you do. So like I said, if we roll the dice even 100 times and maybe 30 times and the number 3 came up, okay, we want to know how many times 3 will come up in 1,000 trials, so we use that actual results that we've got there, multiply it by 1,000, and then we get, well, we expect it to come up this many times, okay. If the number of trials is large, then experimental probability is likely to be close to the actual probability of the event. So the more trials we run, okay, then we're more likely to get answers, or the probability of what the actual probability is. So if we roll, again, if we're after this number 3, when we roll a die, we may roll the die 10 times and 3 may come up 4 out of those 10, for instance. Okay, but if we continued to roll the die lots and lots and lots of times, 1,000 times, okay, it'll probably end up evening out and we'll get an event, the probability of the 3 coming up is 1 out of 6, would probably get very close to that. Okay, so the more trials you do generally gets you very close to the actual probability or theoretical probability, I suppose, of that particular event occurring. All right, wouldn't be exactly, okay, but it might be sort of between 1 and 1.5 out of 6, might be sort of your answer there. All right, so a few things to get your head around. Again, that formula is really important. Okay, you are going to use your experimental probability of results and the trials that you occur to then make predictions. Okay, and just be aware that the more trials you do, the more accurate results you'll probably end up getting. Okay, all right. Your turn. You are going to pause this video now, okay, and you're going to answer this question. So when playing with a spinner, and on that spinner you've got numbers 1 to 4 on it, okay, so we've got our spinner here, for instance. It's split up into 4 equal sections. They're all numbered 1, 2, 3, and 4. Okay, there's our arrow for our spinner. We spin that spinner, and the following numbers come up. All right, and we have done, how many trials have we done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we spun that we spun that spinner 10 times. Talking really interestingly today. Okay, so based on that, I want you to answer questions A, B, C. Let's see if we can get this video under 10 minutes. So pause it now, have a go, and then come back and we'll see what our answers are. Off you go. Okay, hopefully you've had a go at these questions. Let's get into it. So what's the experimental probability of getting a 3? Okay, so remembering that's our formula, number of times an event occurs, total number of trials. So straight away I'm going to go, well, I know my bottom number here is going to be out of 10, straight away. Okay, based on that, number of trials, we did 10, we worked that out before, spun it 10 times. And getting a 3, so how many times did the 3 come up? 1, 2, 3, 4 times. So hopefully you got 4/10, and then hopefully, you're still applying the stuff that we've learned throughout the year. We simplify that. So 2 being our highest common factor, 2 goes into 2 4 times, 2 goes into 10 5 times. Okay, so we get our actual answer there of 2/5. All right, simple as that. What's the experimental probability of getting an even number? So again, so I'm going to do my answer up here for this one. 10 straight away. We've done 10 trials, so my bottom number is going to be 10. And how many even numbers did we get? Well, there's a 4, there's 1, there's a 4, there's 2, and there's a 2, so there's 3. So 3/10, can't simplify that. That is our answer. All right, so 3/10. So the number of times an even number came up, which is 3 times. And how many trials did we have? 10. All right. Okay, last one. Based on this experiment, how many times would you expect to get a 3 if you spin 1,000 times? So this is what I was talking about earlier. Okay, about, predicting, whoops, not that one, predicting results, okay, or getting expected number of outcomes. So, getting a 3, so we've already got the results of the 3 is 2/5, okay, so we'll take our 2/5, so we're going to, based on the experiment, if we did this experiment now 1,000 times, we spun that spinner 1,000 times, how many times would a 3 come up, would we expect? Okay, well, how many times would we expect a 3 to come up would be a better way to phrase that. So 2/5 was what we got. Okay, and we multiply that by 1,000. All right. Now I could do all this, cancel things out and multiply it that way. Actually, I will do that. I will do that. Okay, let's do it as if we're multiplying our fractions together. So I'm going to simplify this way with a 5 and 1,000. So 5 goes into 5 once. 5 goes into 1,000. How many times? So 200 times. Okay, so our fraction here is now 2 over 1 multiplied by 200 over 1. Okay, multiply top and bottom, can't simplify that any further, so I'll multiply my top numbers. So 2 times 200 is 400. 1 times 1 is 1. So that's just 400. So how many times, if we spun the spinner, I'm saying that well now, 1,000 times, how many times would we expect a 3 to occur? We would expect it to occur about 400 times. Okay, so that's how we do it. You could also use your calculator to do that. So let's quickly bring the calculator up, get rid of that old one. So 2/5, so remember 2 divided by 5, I can do that. Gives me that, multiply that by 1,000. 1 more 0, 400. Okay, so that's the other way that we could do that. using a calculator as well. Come on, work. Sorry, I'm going to get rid of that. Okay. We've just hit 10 minutes, and again, I've just finished, so hopefully that makes sense to you. That might be the one that some of you need to work on a little bit more, okay, getting the expected results based on our actual trials, but hopefully that makes sense to you, so you're ready to go on our last exercise. All right, thank you guys, and I'll see you next time. Very quick joke before I leave. Did you hear about the guy who invented the knock jokes? Yeah, he's been nominated for a Nobel Prize. Yeah, quality. Champagne comedy. Thank you guys. See you in class. Bye-bye.